So now we come to the last part of the story, which brings everything together. It's called the Great Salinity Anomaly. Okay, but it's linked to the circulation pattern in the northern Atlantic, linked to the Arctic Ocean. And here's a sketch that I showed before. But what essentially happens in the Arctic Ocean, how it is connected to the North Atlantic, is it produces an outflow. It produces an outflow not only of surface water, but also through the modulation of water masses in the Greenland Sea. It also feeds the deep circulation of the ocean, which is shown here as the blue branch. It's the outflow and the formation of these deep western boundary currents. And on the other hand, you have a return flow. The return flow comes from the surface of the North Atlantic Ocean, and it's connected. It appears as a subsurface layer of warm water in the Arctic. And this entire system is coupled. And it is linked and can be manipulated through the amount of ice that is formed or ice that is melted. So let's have a look at observations of salinity anomalies in the North Atlantic water. And this is linked to something we call nowadays the Great Salinity Anomaly. So let's have a look on the next slide. What it shows is the time series of salinity in the Atlantic layer, in the northeastern Atlantic, at different depths. Okay, all the depths are shown here from 50 meters to 800. Okay, and this is a time series from the 1950s to 1990s. So over 40 years. Okay, the x-axis, the 40 years time series, and on the y-axis it shows you a salinity anomaly. So anomaly is a variation, okay, compared to the average value. Okay, oops, I don't know what happened here. And what you can see is that in the 1970s, mid-1970s, is the appearance of an anomaly. Okay, it is a drop in the salinity that you can see in most layers here. Okay, so what is the reason of this great salinity anomaly? Okay, it's not called great because it's a significant value. We're only talking about a unit change of 0.1 of a salinity unit, which is not very much. It's called great because it was the first discovery of feedback mechanism in the North Atlantic, which is a significant scientific achievement. So now what happens, you can actually look now at observations, and we looked at temperature observations to trace water masses. You can actually look at all pieces of information that you have and try to track the great salinity anomaly through the North Atlantic and the Arctic. Okay, and this is shown on the next slide. On the next slide, so you look at all observations of salinity observations, and then you can reconstruct the history of this great salinity. And it turns out that it started in the late 60s and originated from the Arctic Ocean. It followed the East Australian current into the Labrador Sea, and then around 5 years later, it arrived back and recirculated and could be identified in the northeastern, here in the mid-70s. That's just what I showed you on the previous slide. And then ending up returning into the Arctic. So this is the root of the Great Salinity Anomaly. Okay, and how it actually started is with an anomaly of the amount of fresh water and ice that was pumped into the Greenland Sea. Okay, that created a low salinity, and the low salinity circulated through the regions. Okay, there's an interaction happening between the ice and the ocean, okay, and the circulation in that system, okay, which could be identified and traced in the North Atlantic. All right.